Okay, hello, welcome back to our grade 9 maths lesson. I am Mrs. Ray, your teacher. In our last lesson or our previous lesson, we looked at indices. In today's lesson, we are going to look at the laws of indices or the rules that we use for indices. Okay, we have the laws of indices. Now, we'll start with the first rule. When multiplying indices with the same base, we add the powers. Now, let's say if I have a to the power of 2 times a to the power of 3. Now, I can write this in an expanded form, which is a times a times a times a times a. And that gives me a to the power of 6. Now, we can see from here that when we are multiplying powers with the same base, we simply add the powers to get a to the power of 6. Therefore, we say a to the power of 2 times a to the power of 3 is equal to a 2 plus 3, not a to the power of 6, but a to the power of 5. So, that is equal to a to the power of 5. Now, rule number 2, dividing indices with the same base. What is the rule for dividing indices with the same base? Let's see. If I have a to the power of 5 over a to the power of 3, now, if I write it in an expanded form, that will be a times a times a times a times a over a times a times a. Okay, this cancels out. A into a is 1, a into a is 1, a into a is 1. So, now we are left with a times a times 1 times y, which is a to the power of 2. So, we can see that when we are dividing indices with the same base, we subtract the powers. So, a to the power of 5 over a to the power of 3 is simply a 5 minus 3, which is equal to a to the power of 2. Now, let's see what happens when we have a negative index, or if an index is, a number is raised to a negative power. Okay, we have a to the power of 2 divided by a to the power of 5. Okay, we have a times a over a times a times a times a times a. Okay, this a cancels out. This a also cancels out. So, in the denominator, we have 1 times 1 over numerator. How many a's are there that multiply by itself? There are 3 a's. So, 1 over a to the power of 3. So, a to the power of 2 divided by a to the power of 5 is equal to 1 over a to the power of 3. Now, let's see what happens when we apply the rule of dividing powers with the same base. Now, if I have a to the power of 2 divided by a to the power of 5, now when I apply the rule for dividing indices with the same base, this is now a to the power of 2 minus 5. And that will give me a to the power of negative 3. So from this, we can come up with a rule for negative indices as a to the power of negative 3 is equal to 1 over a to the power of 3, which is this one here. And this one combined together. Therefore, when we raise an index to a negative power, the answer will always be equal to the reciprocal of that number raised to its positive power. Now, let's look at rule number 4. Rule number 4 is on zero index. What happens when a power is raised to a 0? Okay, we have 3 to the power of 3 over 3 to the power of 3. Now, we have already seen that they have the same base. So, 3 to the power of 3 over 3 to the power of 3 is the same as 3 to the power of 3 minus 3, which is equal to 3 to the power of 0. Now, we are going to see by using the expanded form why we say that when a number is raised to 0, it will always be equal to 1. Let's look at 3 to the power of 3 over 3 to the power of 3 in an expanded form. That is 3 to the power of 3 over 3 to the power of 3 is equal to 3 times 3 times 3 over 3 times 3 times 3. And this cancels out, that is 1. When 3 into 3 cancels out, that is equal to 1. 3 into 3 cancels out, that is equal to 1. 1 times 1 times 1 is 1. So from this, we can see that 3 to the power of 0 is equal to 1. Therefore, rule number 4, if a number is raised to the power of 0, it will always be equal to 1. Let's look at rule number 5. What happens when a power is raised to a power? Let's look at rule number 5. We say for rule number 5, if I have 3 to the power of 2 raised to the power of 3, that is equal to 3 to the power of 2 times 3. We multiply the powers, so the answer will be 3 to the power of 6. We can also show this using the expanded form to come up with the rule where we multiply the powers when we want to find a power of a power. So, 3 to the power of 2 is the same as 3 times 3 times 3 times 3 times 3 times 3. So, that will be equal to 3 to the power of 6. 3 times 3 times 3 times 3 times 3 times 3 is 3 to the power of 6. So, the first 5 rules state that for rule number 1, when you are multiplying indices with the same base, you simply add the powers. Rule number 2, when you are dividing indices with the same base, you subtract the powers. Rule number 3, if an index is raised to a negative power, that is equal to the reciprocal of that expression raised to its positive power. Rule number 4, any number raised to the power of 0 is always equal to 1. And the final rule, to find powers of a power, we always multiply the powers. That is if you have numbers which are raised to positive powers. But now, how do we write expressions of indices which are raised to fractions? Let's look at one example. Okay, that is on fractional index. If I have a to the power of half, that is equal to square root of a. We use the set symbol to replace the fractions. Okay, if I have a to the power of 1/3, that is equal to cube root of a. Now, if I have a to the power of 5/4, the numerator always becomes the power of the base and the denominator always becomes the nth root. So, this one will be written as a to the 4th root of a to the power of 5. Okay, that brings us to the end of our lesson on the laws of indices. Okay, now in our next lesson, we are going to look at the application of the laws of indices when you have multiplication, division, or all 5 laws combined together. How do we simplify that? That is what we are going to look at in our next lesson.